In this module, we'll take what we've learned and build a complete weather app. This will talk to a live API, autocomplete cities, perform geocoding, fetch and decode weather data, implement persistence, and architecting for data sharing across screens. We're going to use the Open Weather Map API, which is free but requires you to sign up first. Using this API, we can build something realistic and representative of real app development. In the app, you'll be able to search for a city name. So I'll click up here for the plus, and we'll type Houston. And as I type, I get some autocomplete suggestions. And this is similar to what we've covered already. So if I add a city, it will show a city tile here. And those cities will show you the temperature and the city name. And I can add another one here. So we'll add Houston. And these will be saved. So the next launch, I can hit delete city. The next launch will only have the cities that we have in this list. That way we don't need to add the city every time. Then tapping on the city will show you the current weather conditions for that city. We've got current weather conditions here, as well as the forecast for the next few hours and the forecast for the next few days, including, the conditions, the chance of rain, the high and low temperatures. So in this module, we're going to focus mostly on the combined specific stuff. There is a fair amount of UIKit stuff that might be fun to learn, and I will leave that for you to explore on your own if you wish. Okay, so let's get started. To follow along in this module, you'll need your own Open Weather Map API key. And to get this as free, you can go to openweathermap.org and then go over here to sign in. And if you don't have an account already, you can create an account for free. I will sign in to my account, and then we'll go over here and click on API keys. And here we can click on this to create a new API key. And these are free, but they're rate limited and throttled. So unless you're paying for an account, this is really easy for us to use during development, and it'll allow us to make authenticated calls against this API, which is kind of a realistic example. Now, I can't share my key with you because that means everyone who downloads the sample will be using the same API key, and we could potentially be rate limited, which would prevent some people from actually being able to run the example. So you'll definitely need your own key for this. So go ahead and copy that and put it on your clipboard, and then we're going to move over to Xcode. Now, once you've downloaded the sample and you open it up in Xcode, the initial build will fail, and that's because it's missing this file right here. And what we need to do is right-click on this configuration folder here and click Show in Finder. Once you're there, you'll see the secrets.xcconfig-template. And I'm going to hit Command-D to duplicate that file, and we're just going to rename this secrets.xcconfig. Now back in Xcode, we can see that secrets.xcconfig is no longer red, and we can click on it to put our Open Weather Map API key in here. Once you're in here, delete these comments at the top and put your API key there. We'll save and close that, and we'll do a build for our project. Now we can ignore this project integrity issue because this will go away the next time we open Xcode. So now that we have that API key embedded, now we can make authenticated calls against the API. If you want to take a look at that now, we can. We'll scroll down to this WeatherKit target, and this is where I've gathered all of the functionality about fetching weather and storing it, and talking to the API and decoding and our models and things like that. Basically, everything non-UI specific is going to go in here, and this would allow us to use this in another context like a tvOS app or a Mac app or something like that. If we go over to the API section here, this is where we can see how we're making authenticated calls against their API. And this is where it's going to grab the Open Weather Map API from our info dictionary. Our info dictionary, if you're curious, will be taking that, and it's basically getting it from our xcconfig and putting it in the info.plist. And so that's how that secret gets sent over to the API. And then what we have is basically one single API call, which Open Weather Map calls the one call forecast. And you call this one call endpoint in order to get basically an aggregate forecast that includes current conditions, hourly conditions, and daily conditions for a given latitude and longitude. And so this is the only API endpoint that we need to really deal with. And we're using this, which essentially uses the same HTTP combined pipeline that we built in previous episodes. So that's the extent of the API. It's pretty simple. We need an API key, which we have defined already, and we'll need to be passing in latitude and longitude in order to get back a result. Now, if we take a look over here in the models, these are the models that'll come back from that API. And we've got one call results. This is kind of the top level response that we'll get, and it'll have current, hourly, and daily. And I've organized these into something called weather metrics. And I made a generic over a temperature type. So for the current temperature, we'll get a single temperature. For hourly, we will get an array of weather metrics of single temperatures. And then for daily, it's a little bit different. And so I've changed that to daily temperatures. And daily temperatures have things like the day temperature, I guess what that feels like during the day. You've got a min and a max, which might be optional. You've got a nighttime temperature, an evening temperature, and a morning temperature. So these are all how temperatures are structured when they're represented in a single day. And so that's why I have isolated those into what I call a temperature container. And that's just a protocol that we can use so that when we have a weather metrics, which is defined here, it can use one of those temperature containers. And inside of weather metrics, we'll get the date, that temperature type, feels like, which is also that temperature type. So feels like will also give you min and max and things like that. You also get things like pressure, humidity, and some weather conditions. Weather conditions will have an icon and a description. So this will be like thunderstorms or cloudy or things like that. And I think that's enough information about the API that we need to do. So basically, we're just going to be getting this one call result. The next thing I want to talk about is I'm using this thing called a timed cache, which will take any codable model and put it in this cache dictionary here, as well as persist it to disk. And I'm doing this because during development, you may want to run this application many, many times, and you may be fetching the weather for the exact same Latin long many times over the course of a development session. And I want to avoid this causing you to get rate limited. So what we're doing is we're saving this into our caches directory for application and just saving these as JSON files. And we'll do that and make sure that our expiration date is not matched. This will allow us to pull an item out of the cache if we already have it, which will avoid going to the API entirely if it's unnecessary. And so when we are setting this, we can pass in an expiration date and say that, okay, I'm going to cache this single weather item for maybe 1 hour or 6 hours or an entire day or whatever. And so this will aid us during development. Now, in a real weather app, you probably want something a little bit more up to date. And of course, you would have to pay for an API that would support that level of access for all of your users. Okay, so that's an overview of the WeatherKit framework. And we can now get started on building out our UI for this application. Okay, so let's talk about how we can autocomplete cities. So when you tap on this, you're going to get the Add City View Controller, which we can go find over here in this Weather App group under Add City. And we have an Add City View Controller. And if we take a look at this, we've got a Table View Controller. It's got a reference to its view model. And then we've got a published property for a chosen city. So this is what's going to happen when we've actually completed the whole workflow for this. It will dismiss and add the city to this main screen here. So that's kind of the output. That's what we need to drive toward. But we don't have that yet. We also have this result. And so when I am auto-completing the cities, I need to show them in the table view. And we're using diffable data sources, which require its and for the snapshots, it requires the items to be identifiable if it wants to efficiently animate in the new results. Otherwise, you'll just get kind of a reload behavior. And I want these results to essentially be considered unique. And so I'm adding a unique ID to each one of those. And it just has a title and a subtitle. So however we're planning to get these cities in this list, eventually we need to transform them into results because that's what's going to drive these cells in the UI. Next, we have some methods to configure our table view and to configure our search, which is going to essentially send the items that we search for. So in the search results updating protocol, we will take our search bar's text and send it into our view model as our search term. So let's go over to the view model and take a look. That is this search term here, and that is using Search Completer. And this is a type provided by Apple in the MapKit framework called MK Local Search Completer. Now, this is really meant to search for places around you, like coffee shops and restaurants and things like that. However, I'm going to sort of abuse it to search for city names because it will also show those cities in its results. Also in our Add City View model are published properties for the actual results that we're going to be publishing. So that's that struct I showed you a minute ago, and a published property for whether or not we're actually doing some work, in which case the UI should be showing a spinner. So when we initialize this view model, we'll set search completer delegate to self. And then when the search bar has new text, it's going to send that text into the search completer. So if we scroll down, we also have a snapshot publisher. And so this is going to take any of those new results that we have and apply a snapshot. So here in our viewed load, this is a good place to set up our subscriptions. So we're going to look at our view model and we'll first grab the results from the show spinner publisher, and we'll sync to get a value here. And I'm going to use unowned self in. And if we have a spinner, so if $0, that means we should be spinning, then I'm going to look at the navigation item dot write bar button item, and I'm going to set that to a new UI bar button item with a custom view of UI activity indicator view. So when we go from false to true, it'll create a new spinner. And if it goes to false, then we'll set write bar button item to nil. And then we can store this subscription in our cancellables. So now our view model is entirely in control of when to show a spinner and when not to. Next, we can take our view model's snapshot publisher, and we can also sync on that and use unowned self in. And here we want to take our diffable data source and we want to apply that snapshot. So here we'll get a snapshot in, and then we'll say animating differences true. You may want to play around with animating differences false or true. It depends on if you want these animations. It may feel faster if the animation is off, so I'm going to leave it off for now. So then we'll store that in cancellables, and that'll address this warning. And now we've set up, our basic subscriptions for a view controller. Now we need to turn our attention back to the view model. Now, when we send new results into the local search completer, it will say completer did update results with our results. So this is a case where we have an existing API that I want to now participate in the combined world. And so to do that, we're going to use a subject. So I'm just going to go up here to the top and we're going to create a private var completions subject. And that's going to be a current value subject with a value type of an array of MK local search completion. And we'll use never as our error type. So now we've got a subject that we can use. And since it's a current value subject, I need to pass in an initial array here. So I'm going to pass in an empty array. So next, down here at the very bottom where completer did update results, I can just say completion subject.send and pass in the completer's results, which is an array of MK local search completion. So now what we need to do is take that and convert it into these published results here. So we'll do that in our initializer here. So we're going to take our completions subject and we need to map those. And that's going to give us all of the completions. So remember, this is not the standard library map that's going to operate on a single item in the array. It's going to operate on the whole value coming out of the subject, which itself is an array. And inside of there, we can take that and map that into our add city view controller's results type, and then give it a $0.title. And this is from the completion. And then for that, we also have a subtitle that comes from the completion. So we've mapped one array of completions into a new array of our results. And then we can assign that directly to our published property of results here. Now this is all going to happen pretty fast, so I'm not going to show a spinner in this particular case. We're going to save that for when we're actually geocoding, because that will happen a little bit later. So let's see what happens when we run this. I should also mention that I know that these results are going to come back to us on the main queue, but if you didn't know that, then you might want to add in on the completion subject here after you've mapped it to receive on the main queue, because this is definitely going to be driving the UI directly. So let's go open this up and we'll start typing the name of something. So I'll type in HOU and notice that I get Houston, Texas, but I also get Houston's restaurant and the subtitle is search nearby. So this is kind of what's happening if you were to search for this inside of Maps, because you're searching for places and also locations. And so I get quite a few things that I'm not exactly interested in when, I don't need to know the weather at House of Shabu Shabu. So what I need to do now is figure out how can I use this API to just give me city names. Now, there are many other ways you could do this. You could use Google's API and, there's OpenWeatherMap maybe have an API for this, but this comes built in. And one thing I noticed when working with this API is that all of the ones that I'm interested in kind of have commas in them. So if I search for Dallas, notice I get Dallas, Texas, and this one has commas. And so that's really what I want. I don't want the ones that look like places. I want the ones that look like cities. And so inside of here, before mapping to our results, I can use Swift's filter, the standard library filter, and just make sure that the title contains a comma. So this is good enough for our example. This will filter out all of the results that do not look like places. So now if I search for Houston, I get Houston, Texas. I can search for Dallas, I get Dallas, Texas. I can search for Cleveland. And I think this will be good enough for us. So the next thing we need to do when we tap on this, we can't take this result directly. We need to know exactly what the latitude and longitude of this item is before we can create our city. So let's go look at our model that we're going to be creating. This is the model that we need to create in order to successfully fulfill the workflow for the screen. I need to create the name, the locality, and the latitude and longitude. And so this latitude and longitude are going to come from CL Geocoder, and I can use the name from our result that we've already specified here. So let's go back over here, and we're going to go back to our view controller, which is going to handle what happens when we tap on one of these items. So if we go over down here to where the table view did select row at, now we need to geolocate the city. And I want that to be a function of the view model, not the view controller. So here I want to say something like viewModel.geolocate selected index maybe, and then pass in indexPath.row. So let's go back over to our view model and we'll define that method. So we'll go down here and we'll add a function called geolocate selected index, pass in the integer, and this will return in any publisher of a city. And we're just going to ignore errors for now. So the idea here is that I can take the result for that selected index, and let's quickly assert that the index that we're passed is less than the results.count, just to avoid that potential issue. And I need to get the result out of our results array for that index. Now I can tell the UI that it needs to show a spinner because we're going to be geolocating that address. And then we have a geocoder as a property on our type here. And so if it already had a request, I want to cancel any previous requests that it was running. And I forgot to give this a variable name. So we have our result. And geocoder works like this, where you can say geocode address string, and then you get a completion handler. And we talked about how we can transform these APIs into a combined publisher using future. So that's really what I want to do. We're going to return a future here. And at this point now, our future is going to eventually be type erased to any publisher of city. So we need to eventually turn whatever this is into a city. But we're going to start first by taking in the promise that our future provides. And now we'll use self.geocoder.geocode address string, and we're going to pass in results.title. So that's going to be passing in one of these over here. So we will do that, and then our completion handler is going to give us an optional array of place marks or an error. So at this point, I am fairly certain that this is going to happen on the main thread, but if it doesn't, I want to know about it so we can handle that properly. So I'm going to use an assert thread.isMainThread. And so this will crash for us if that assumption is not true, and that'll allow us to chain on a receive on onto this so that we can properly communicate back on the thread that we intend to. I don't want to just throw receive on the main queue because that adds unnecessary dispatch queue.main.async. So then I want to set show spinner to false. And if we got a place mark, I'm just going to get place marks question mark dot first. So if there is one, then we're going to tell our promise that we succeeded. So we'll success with that place mark. Otherwise, we're going to fail the promise. And we can use failure errors.geolocation failed. So that's an error that I've defined in this errors type. So what we're defining at this moment is a publisher that will return a value of either a place mark or an error. Here, let's go ahead and say that we can communicate that error back up by changing this never to an error. And we'll let the UI handle that as necessary. So here we will geocode our address. And then now further down the chain after our future, now we need to map that. This is going to give us a place mark. And I'm going to put in the types here to make this a little bit more obvious that this is a CL place mark, and I'm going to return a city. So at this point now we need to take that city, which will take a name, locality, latitude, and longitude. And here we can use the placemark.name, which is optional. So if that's nil, then we can use placemark locality. And if that's optional, or if that's nil, let's just return unknown city. Then for the locality here, we can use placemark.administrative area, which is also optional. So we will nil coalesce that into placemark.country. And if that's optional, we'll just return an empty string. And then here, placemark.location is provided, but that's optional. And we need to get the coordinate.latitude out of that. And if that's not provided, I'll return a 0. And then here, placemark.location.coordinate.longitude or 0. So if this ends up giving us some junk data, then we'll end up with some junk results in, geocoding some weather for, in the middle of the Atlantic Ocean. But I think this will work for now. The other thing we could do instead is use try-map here and throw any kind of invalid city errors and let the UI handle that as necessary. So at this point, now we have converted our place mark into a city, and now I just need to call a race to any publisher, and that fulfills our contract there. Let's see, I misspelled place marks up here at the top. And now we've got our geolocate function. So it'll show our spinner, cancel any geocode. It will convert a geocode request into a promise, or rather into a future, and then map that future results to a place mark, or of a place mark into a city, and then a race to any publisher. Okay, so back on our view controller now, this guy is going to be giving us a publisher that is either an error or is a city. So for now, what I want to do is catch errors, and here I can say error in, and we just want to print out, unable to geocode. And I want it to continue. And so I want to return a nil. So I can just say return just nil. Now this isn't going to work because the type of this upstream publisher is an actual city, not an optional city. So I'll need to map that to $0 as city ? So that those types will match up. And I'll also have to tell it that I return a just publisher with city optional like this. So the idea here is that I'm just saying unable to geocode, and we can even pass in the error. And this is where we might show an alert or something. Then I can compact map to ignore any nil values that are coming downstream, and then assign this to our publisher for chosen city. So we subscribe to the geolocate publisher and assign the result to chosen city. So now when you tap on one of these, it will ask the view model to geolocate that city. We'll get an actual city, and we will pop back to the screen that presented this, which was the My Cities screen. So My Cities view controller. And if we look at Add City Tapped here, at this point, this is where we presented that screen, and now we need to handle that chosen city. So let's first take a look and make sure that we're getting one. So I'm going to look at add city VC $chosen city, and let's just sync and receive the value here. City in, and we'll print chosen city, and we'll pass that in there. And then we need to store this in our cancelables, but notice how add city could be tapped multiple times, and we really only want to subscribe to the latest one that is presented. So instead of storing this in cancelables like you would for like a long running subscription, this is kind of a single operation and then be done type of scenario. So for that, I'm going to use this chosen city cancelable here at the top. We will assign that to chosen city cancelable equals this. Okay, so let's go ahead and run it and see if we get a city in there. So we will do that, and I will type in Houston. We'll tap on it and see if we get any results here. Chosen city, Houston, with latitude and longitude. Okay, now one other thing I want to point out here, it says chosen city nil here, and that's because when you subscribe to a published property wrapper like this, it's going to emit the value immediately. And we're not at all concerned with that first value. So what I want to do is say drop first. And then after that, we want to sync to receive that value of that city like this. So we only really get the valid cities. Now at this point, once we've chosen the city, I'm going to say add city navigation controller .dismiss animated true completion nil. So now we need to actually do something with this city. So once we've dismissed this navigation view controller, we're going to be sitting at this screen here, and I want that city to be there. So we're going to need to figure out how we're going to save the city and have this screen show the results. And lastly, I realized that the spinner is not actually working. We've got to do two things to fix that. One of those is when we are about to geolocate a city, I want to tell my search controller, which comes on navigation item, search controller is active, and set that to false, which will hide the search bar and the cancel button so we can actually see the navigation bar again. And then up here where we're configuring this, we actually need to create the indicator separately, UA activity indicator view, and then pass that in here so that I can say indicator.start animating. And with that change, we should see the activity indicator when we are geolocating. We should see it dismisses, and we see it really quickly. But this all happens pretty fast. But if you're on a slower connection or if it took a little bit longer, then we'd be able to see it. So now that we've chosen a city, we now need to do something with it. And in a traditional approach, you might add this to a local array and then tell the table view or the collection view or something to reload its data. But we want to do this in a functional way where we're mutating the model and saving it. In this case, I want to save it in a persistent way so that next time you launch the app, it'll have the city there. And then we need this screen to react to any changes in our model. So what I'm going to do is introduce the concept of a store. So a store here is going to be an abstraction around the persistence of our cities. So we'll call this cities store. Now I like to do this type of pattern when we're abstracting around the actual underlying data storage mechanism, whether that's flat files or user defaults or returning stuff from core data stores or maybe even CloudKit or Firebase or something like that. And so this way you can kind of treat it in one way, say this is a city that I need to save, and then let me know if anything changes. So we're going to create a public class for cities store. And for this, to keep things simple, I'm going to use user defaults to save these in a JSON array. So we're going to have a published property of cities like this, and then a public initializer that will take in its array of cities. Then we're going to have a public static load method that's going to return a city's store that is loaded from its persistent storage. So that needs to be a func. And I'm going to create a private static let user defaults key equals cities. So here we're going to get a JSON decoder, and we're going to try to get the data from the underlying user defaults here. So we can say user defaults.standard.data for key, pass in user defaults key. If we didn't get any data, then we can just return our cities store with an empty array of cities like this. And then here we can do a do catch, because we're going to try to decode this. And if it's in some sort of bad format, it's going to fail. So this will be a decoder.decode an array of city.self from that data. So that'll be our cities. And then if that worked, then we can just return cities store, initializing with that cities array. Now, if it didn't work, then we had an error, and I just want to print it out and continue. So error decoding cities, and then we'll just dump the error there. So if we ever run into a situation where we change the data format, then this obviously isn't going to handle that, and we have to do something. So I'm just going to return an empty array of cities here. But obviously, this is something you really want to avoid, changing something so that it can't be decoded later. So this gives us our basic structure for loading from user defaults. And then we're also going to need a public func for adding a new city. And this brings up a good point where I want to make sure that all of my mutations are funneled through these add and remove methods that we're adding. So I need to make this a public private set. So we'll make this public private set like this, so that an external piece of code can't come in and just swap this array out for something else. So here what we're going to do is add to our cities array, appending the new city onto the end. And then at this point, we need to figure out how we're going to save this back to our store. We can make a public func save. And this will throw, because if we can't encode it, then we have a problem. So let's work on that. We'll make a JSON encoder, and we'll encode the cities array, which means it needs to do a try. That's going to give us back data. And then we can say user defaults, standard set data for key, and pass in the user defaults key, which is on self. Okay, so now the question is, when do we save? And I'm going to make the argument that just for the sake of this example, it's actually nice for us to be able to save right here after we add it. In a real application, you may want to wait until the application goes into the background, or listen for the application will terminate and save then. But the problem is that when you hit stop in the debugger, it's not going to run any of those events. And so you would basically never have a chance to save during development. So another option may be to wrap this in an if debug setting. So you don't do it in a real app, but you do it in development. But I'm going to add those for now. So now I need to remove the city. So we need to check to see if we can get the index, which will be cities.firstIndex of city. If we didn't get an index, then this city doesn't exist in the array. And now we can say cities.remove at index. And again, we'll save after we've made that change. Okay, so this is our completed cities store that saves as JSON into user defaults. And I think this is okay for lightweight data, but you do have to be careful to make sure that the data that you saved will essentially be perpetually loadable in the future, so you don't lose data for a user. Okay, so now the question is, how do we get access to this throughout our application? And I've chosen a pattern that I've been using more and more lately, which is to have sort of all of your dependencies and services and things like that, rather than making them all shared everywhere, is to attach them onto a struct that I'm calling world. And this is a technique that I learned from Steven Sellis, which I will link to his talk where he introduced this pattern. And so what I want to do now is have a cities store here, which will be a cities store. And the idea here is that these are immutable so they can be swapped out in a test. But in our real application, we're going to create actual instance of those. So we'll do cities store equals cities store, and I want to call the load function. Now we'll have to do a build so that it picks up that new public type in the WeatherKit framework. But at this point now we have our current is a global that we can access anywhere, and it will allow us to access the weather API as well as our cities store. So let's go back over to MyCities view controller where we were saying do something with the city. So we're going to use current.citiesstore.addCity. And at this point, city is optional in this block. And so we'll have to unwrap it like this. And we'll move that up in the block. And I'm also going to move the print statement down inside that block as well. Okay, so now we've handled the results of this add city flow. You can think of this as kind of like a workflow. We present a screen to add the city. The responsibility of that screen is to search and geocode and return to us a city model, which it does. And at that point, now we save it to the store. Now I want to avoid telling the view controller or the view model or anything like that to react to that change here, because we should set up that reactivity basically in view-did-load, so it will react to any change of any city anywhere in our application, because it should be watching the city's store. And this is kind of a key point to functional reactive programming. You mutate the model and you let the reaction sort of drive the rest of the application. We want to avoid imperatively telling it to reload its data here. Okay, so let's talk about how that works. If we look at our view-did-load here, we have a view model snapshot publisher, which I already created. So anytime some data changes, it'll get a new snapshot, and it's applying that on the diffable data source for our collection view. So the rest of that is in MyCities view model, which I will open up next. And right here, you can see that there is a private var cities, which is in any publisher of an array of city view model. And right now we've stubbed this out to return an empty array. So what we need to do now is have access to our cities store. So let's make a quick cities store computed property. And this will just return current.citiesstore. I like adding these sort of accessor properties sometimes because it makes it a little bit easier to swap this out if you decide to change the pattern of how this gets injected. So we can use it like that. And the rest of the file doesn't really need to know that it comes from current. So then inside of here, we need to take those cities. So let's use the cities store.$cities. So we have a publisher for the cities. Now, anytime a new city gets added, it's going to fire a new event on here. And we just need to map that to this city view model. So this map, again, is going to give us cities. And then I need to, again, map those cities inside of there to get the individual cities. So again, we have that kind of pattern where this is the publisher's operator map, and this is the Swift standard library map that's going to operate on individual elements from the array. So at this point now, I need to take that and I need to create a city view model. Now, a city view model takes three things: a city, a weather, and a temperature formatter. So for the city, we already have that. For the weather, it's asking for a publisher of a one-call result. And if you recall, the one-call result is the Open Weather Maps API type for getting like an entire forecast in a single API call. And so I don't have that yet. So I want to just return just nil erase to any publisher. So we can just sidestep this and talk about it later. And then lastly, this also asks for a temperature formatter because this is meant to be used kind of in a collection scenario, and you don't want to create a dozen measurement formatters when they're all the same. So we want to use temp formatter in here. And because this is the only dependency that we're using that is referenced on self, we can use the capture syntax to capture just that object and use that inside the block. And then lastly, we have to erase to any publisher to match up this type here. So at this point, now we just kind of trace what happened. A new item gets added to the cities store cities array. This publisher will pick it up and transform all of those cities into city view models. And because we've already referenced those cities in the snapshot publisher and something subscribes to this publisher will then map those into a full snapshot and send it to the UI. Okay, let's give this a build and let's see if we can add our first city. Okay, we'll click on the Add City button. I will type Houston and we'll add it, and it added a new item to our array. And if we hit Command dot and run the application again, Command dot will kill the, it's the same as hitting the stop button in the bar there. And running the application again, you can see that the city is restored on the next app launch, which means our persistence is working. Now, as you can see, it is not showing the weather temperature, and it's not showing any kind of properties for that. So let's fix that next. Actually, before I do that, I want to talk about this. I've added a context menu. So if you tap and hold on this, we can delete the city, but that's not implemented yet. And so we can test adding multiple cities and deleting them. Let's add that now before I forget. So in here, I'm going to need an access to that city. So that's going to be cities store.cities at the index that they are operating on. That will let us use the city name in here. So I can say city.name. And then inside of here, we need to remove the city. And so we're going to use self.citiesStore and remove city. So let's run this and make sure that this is working. So I've got my city, Houston, hit delete city. Now we can add a new city. Now I'll add Portland. And we get the new city. Let's add Houston again. There we go. So let's focus on fixing up the bindings essentially for this cell. So if we go over here to the My Cities group, we've got My City cell or city cell. And here we've got a current temperature label, which is these two dashes, the name label, which is saying city right now, and then the locality label is the last thing. So this is also has a reference to the cancellables, but this is an important concept to be considering because this city cell can be reused. And because it can be reused, this is kind of a potential breeding ground for bugs that result from subscriptions that we create in the cell. If we create a subscription that is binding a city's publisher, say the publisher for some temperature for a city, and then we reuse that cell for another one, we need to make sure that we unsubscribe from the first subscription. And the best place to do that is in Prepare for Reuse. So any subscriptions we create, we need to make sure that we get rid of them here. Okay, so at this point, we're saying update with ViewModel. So our job here is pretty simple. We've got our name labels text can just come from viewmodel.cityname. And because this isn't a publisher, we don't need to go fetch some data. This is just a simple assignment. And then we can say the locality label.text equals viewmodel.citylocality. Now, the next part of this is getting the view model and looking at the fact we have this current temperature. Now, current temperature is a publisher that is giving us a string, and we want to assign that to a label. And if you recall, we can't assign a string to a text property of a label because it expects an optional string. So we're going to do $0 as optional string to cast the result as an optional string so that we can do assign to text property on our current temperature label and then store this in our cancellables set. So this is the part where we need to, our Spidey sense should be going off. I'm in a reusable cell and I just made a subscription. So if I don't undo this, this thing will always, as long as the cell is alive, because the cancellables will be alive still, even after it gets reused, we need to make sure that we always detach from this. Otherwise, any update for a previous subscription will still update the label. So what we need to do now here is when we prepare for reuse, we're going to set cancellables to a new set, which will detach all of its subscriptions. And then just for good measure, we can also clear out the name label, the locality label, and the current temperature label. That text is important to clear out here because this is asynchronous. This is a publisher, which could get its temperature later. Let's say it took 5 seconds. We don't want to be showing the wrong temperature for those 5 seconds until we get a new value. So just clear out all of the UI related items in prepare for reuse. Okay, and now we can see that we've got Portland, Oregon and Houston, Texas in our list here. And we aren't fetching the weather yet, but we will do that in the next video. Okay, now let's turn our attention to this next view controller, which is city weather. Now, in order to go from our city to the city weather view controller, it's going to go through a segue. So let's go to My Cities view controller and take a look at that segue. Right now we need to get the selected city, and we can do that because we're binding this directly to the array that comes from our cities store. We can get our city directly from our cities store. So we can say cities store, which will come from current, and then get cities at that index. And then we set that or cast the destination of our segue to the city weather view controller, and then assign the city like this. Now, I'm not the hugest fan of using segues like this, and I left it in this example because I want to focus mostly on the combined specific stuff. But in a real application, I'd probably leverage the coordinator pattern for this type of behavior rather than having one view controller know how to prepare the data for the next view controller. So if you're interested in that, I would take a look at the coordinator pattern. Okay, so now that we've specified the city that the city weather view controller is going to be using, we can jump over to that. So over here on City Weather View Controller, this is a plain view controller that has a collection view inside of it. And this one is using the standard data sources instead of using the diffable data sources that we've seen up to this point. And I'm doing this because I think it illustrates an important problem that you might encounter when using data sources in conjunction with combined publishers. So here we've got 3 sections. We've got current weather that's going to be at the top of the screen. Then we've got a strip of hourly forecast for the next few hours. And then we've got a section at the bottom, which is weekly forecast, which will show up as rows. So 3 different sections, all of which are going to be binding from the same essential publisher, that one call result. But we haven't made that request yet. Then we've got our city. So this is being set by the segue. And as soon as it does, it constructs its view model based on that city. So then we set up our collection view. And in here, I want to add some subscriptions to, watch the data so that we can react to when it changes. But real quick, I want to go down to the data source implementation. Right now, the number of items in section for current weather, this is kind of like a static header at the top, and it's just got some simple properties in it, or simple labels in UI controls. So that one is always going to have 1 section. For the other 2, just to let it compile, right now I'm returning 0, but these are going to come from the data. So we'll have if we look in our view model, we have 2 publishers, which have backing arrays. So the weekly forecast is actually going to come from an array of daily forecast models. So that's an array, and I can say, okay, the weekly forecast has that many. And then the hourly forecast, which is the strip of rows for the next few hours, that one also comes from hourly forecast.count like this. And again, these are simple arrays, but they do have publishers attached to them. Now, the hourly forecast actually shows you many hours in advance, and I just want this to fit on one line. So I'm going to make sure that there's a maximum of 7 items returned from this. If not, we'll just return the first 7. So that will allow us to render the appropriate number of items based on the data. And then down here where we're setting or configuring the cells, here I need to say cell.update with view model. This one is going to take a daily forecast view model. So I need to look in our view model and get the daily forecast for this index path.row. And then the same thing for the hourly forecast. So we're going to ask the view model for an hourly forecast for that index path.row. So we've got one view model that's sort of vending other view models for each one of the cells. And then if we go over here and look at city weather, you can see that everything's kind of broken out here. We've got daily weather cell, which has some simple outlets on it, and its view model update from view model is pretty simple. It's just extracting the properties straight over from the view model. And there are no publishers going on here, no subscriptions, so it's pretty simple. And the same thing goes for the hourly weather cell. There's just a time and a temperature label, And so we just copy those over from the view model. The current weather cell is the single cell that'll be at the top of the UI. And in this one, we do have a set of any cancelables because this one is going to be looking at the current temperature from the view model. And as you can see here, that this is just subscribing to simple properties, all of which rely on one single publisher. So the difference here, we've seen sort of two different styles. We've got the section at the top that has one cell in it, and we're always going to return the one cell. And as soon as that cell renders, it's going to need to subscribe to the publisher to know when to update all of its properties. So all of these are dependent on the publisher. However, the other sections in our collection view are already data driven, so we're not going to start rendering them until the data is already there. So that's kind of the difference that we're seeing here. So in this current weather cell, we're setting up multiple subscriptions, and you can see that I've extracted out a publisher for each one of these things that we need. So this view model doesn't necessarily need to know, or at least the cell doesn't need to know, that all of these come from the one call result publisher. It just needs a publisher for each one of its properties. Now, it is important to note that here there's no chance of reuse, so I'm not canceling the subscriptions. But if we needed to use this in multiple cases, then we would want to make sure and cancel, or override prepare for reuse and cancel all these. But I know that this is sort of a static cell. It's almost like a header. Okay, so those are our different cell types and how these things get laid out. Let's go take a look at the city weather view model. And this is where we need to implement our sort of core part of all of this. Every other publisher that we've seen derives from this one. Because this has all the data on it. So for instance, if we go look at, if we scroll down, we've got current temperature. This is a computed property that's going to start with weather publisher and then map it and see if we have weather. If we don't, it's going to return a string with these 3 dashes. And if we do, then it's going to format the temperature. Then we have a similar thing here for current condition image. This is going to take that same weather publisher, this time map it to an image, so it's looking for the condition inside of that response and returning an appropriate image for that. Then we have current high-low temperature. Again, all of these things are just sort of focused on exactly what it needs to provide, and it's all dependent on this weather publisher. So this is how those cells will get, all of these publishers are for that static cell up at the top. And then if we look up here, we've got 2 published properties, and this is what's going to drive the sectioned data sources for the collection view. So we've got daily forecast, and so this is going to be an array of daily forecast view models. And then we have hourly forecast, which is an array of hourly forecast view models. So again, if we look in the initializer for this view model, it's again taking the weather publisher, and it's going to map that to create all of these daily forecast view models, and then assign that to that publisher. Then again, we have the same thing here for the hourly one, and that one will assign to the hourly forecast. So I encourage you to pause the video and kind of take a look and see if you can make sense of how all this is structured. We've got one publisher sort of driving all of this information, and we're exposing all of it as separate publishers so we can subscribe to it as needed. Okay, so what we're not doing yet is implementing this weather publisher. So let's go ahead and take a look at how we might do that. Well, if we look at current.weather API, there is this thing called a one-call forecast for latitude and longitude. And we have reference to a city which has a latitude and longitude, so we can do this. So if we take a look at this call here, we can see that this is giving us a publisher with an actual result or an HTTP error. And this is good because we want to be able to handle errors in a real application. But in this particular case, I just want to kind of swallow the error and return nil, which is why I changed the output type here to an optional one. So here we want to map the type of the upstream publisher to an optional one call result. And then here we can say replace error with nil, which will allow us, oops, I need to add the optional here. This will allow us to replace error with nil, and or you could catch the error and print it and return just nil if you need to see the error. Then finally, erase to any publisher is going to give us this. Now, one thing I want to do is I want to print out the fact that this is making, or, when this is doing its data. So this is the weather publisher. And let's go ahead and run this. So if we tap on Portland, we can take a look and see what's happening here. Okay. So the first thing we notice is that we have a crash. And this crash is related to the fact that there's some sort of background thread layout happening. Now, this is because there's nothing. So we have a lot of stuff that's driving the UI, and nothing has told it to jump to the main queue here. So one thing we could do is in this weather API, we could specify that we want this fetch resource method to always call back on the main queue. So I'm going to say receive on dispatch queue.main here. Okay, so now if we run this, we should see some output here, and we see our results, but you can see there's a whole lot of output. And you can see Weather Publisher received a subscription, and Weather Publisher received another subscription, and Weather Publisher received another subscription, and another one, and another one. And the reason why is because we have all those computed publishers, those computed properties that are all chained on the end of this Weather Publisher. So they're all requesting values. And if you realize what's going on here, all of those are actually making calls to the API, and they're all getting the same result back. And that's because the publishers are going to do their work when they're subscribed to. So you have multiple subscribers to this thing, it is going to do the work multiple times. And that is a real problem when it comes to things that are going to talk to the network. And we don't really want that. Now, I'm going to add share onto the end of this. And this is going to sort of put a Band-Aid over the problem. And because all of these things are all subscribing at the same time, it is very likely that all of them will see the result that is currently in progress and subscribe to that and all get the output from it. But if any of those subscribers come in after the publisher has its result, it's just going to receive the finished event. It's not going to receive the actual value that came down from this API call. So if we run this now and we tap on Portland, notice that now we only have a single value, a single subscription for that, and the results for that are shared with all of the other downstream subscribers. Okay, so right now we're just looking at this first section because this one is dependent on, it returned that one static cell, and those were all dependent on those publishers. But we never told the other cells to reload their data. So let's take a look at how we might do that next. So if we go to our city weather view controller, and here we're setting up our collection view, what we'd like to be able to do is say viewModel.$daily_forecast, and then maybe when that's done, let's receive the value. And now what do we do with this value? Because what we really just want to do is reload that section. So maybe instead of doing that, we can ignore the value and then say self.reload or self.collectionView. Here we can use unowned self, collectionView.reload sections, and maybe here we pass in an index set with section dot. This is the daily forecast, so it's part of the weekly forecast section, and use the raw value. So here, anytime daily forecast changes, we're going to tell the collection view to reload the data. And let's save this subscription. Correct the spelling error there. And let's save this subscription, store in our cancellables. And what we actually need here is an array of sections that we want to reload. Okay, so now we are reacting to the change in daily forecast. We're throwing out the value that we get, and it's telling our collection view immediately to reload. Let's do the same exact thing, but for the hourly forecast. And we'll reload the hourly forecast section. Okay, so if you follow the collection view data source stuff, we say reload, it will go ask for the number of cells, and it's going to look in the array and see how many items there are. Let's see if this works. And we tap on this, and we see that, well, the hourly one worked, but the other one didn't. And the reason why Just making sure there are no errors in here that we see. The reason why it's not working, and this is an important distinction, when these published property wrappers publishers fire, they fire on will set of the underlying data, not on did set. So it's basically broadcasting to external, interested parties, I'm about to change, and here's the data I'm about to change to, but we're ignoring that data, telling it to reload, and then it dutifully goes and asks for the underlying array, and this array hasn't been mutated yet. And so this is a common sort of stumble that will happen if you have this data source where you need to use the data in a different method from where you have it. So in this case, there's not a great solution here outside of delaying the update to happen on the next run loop, like a dispatch queue.main.async. And by doing that, you're just sort of waiting until the property, the underlying property is actually changed. And those types of solutions never feel great. So before I resolve that particular issue, I want to talk about one other style that we could do. So it may look a little bit interesting that both of these discard their values and both of them reload some data. So one thing we could do is, let's say we had the daily forecasts, and that would be viewModel.$dailyForecast. And I'm going to map this to just a void. So daily forecast is now just a signal that daily forecast has changed. Then we could have the hourly forecasts be viewModel.hourlyForecast, and again, ignore the value and return void. So now I've got two publishers that look exactly the same. So I could say df.merge with HF, and when either of those change, we could sync, ignore the value, and then say, let's do unknown self, collection view, dot reload data. Now, we still have the same problem that we're observing these publishers. They're going to fire before the underlying properties have changed. But we've now sort of combined those two into one. Then we can store that in cancelables. And but the interesting thing to point out here is that these two things are essentially going to fire at the same time, and I don't want to reload data twice. So what we could do is use debounce here and just maybe debounce for 100 milliseconds. Dispatch queue.main. And this would essentially do the same thing that I mentioned earlier, which is kind of a coincidental fix that by the time this debounce timer times out, it will allow any of the updates that happen in any of these upstream publishers to proceed downstream. And then that means if they both fire at the same time, we're only going to get one event in the sync, which means we reload data. Now, this will solve the problem because we are waiting before we access those values. But I think this is kind of a coincidental fix, and it doesn't address the underlying problem. So I will leave this commented out because I think it's an interesting solution, but I think the solution that I would go with is by caching the values just for our data source. So here we'll have a private var for daily forecasts, which will be an array of daily forecast view models, and make it empty. And then in the did set for here, we could tell our collection view to reload these sections, and we'll use index set section dot weekly forecast dot raw value, and then just do the same thing for hourly forecast here. And that'll be hourly forecast view model. And this one will reload the hourly forecast section. So we just have two properties that are essentially just going to copy the values from this. So instead of reloading the section here, we will set, and definitely don't ignore the value, we're going to set the daily forecasts equal to $0 like this. And then this one, same thing, hourly forecasts equals $0. Okay, by doing this, now we need to go down to where they are used, and instead of using them from the view model, we can use them from our local properties, which are the cached versions of those. Okay, so now we're getting a crash because we're using the view model here, so I need to update that as well. We'll do that the same for both of these. Okay, so now we've solved the problem by caching the data that comes from those publishers. And really, there's no right answer here. I wanted to point out that there are multiple solutions for how to solve this problem, but I think it is pretty common for people to get tripped up when subscribing to a property wrappers publisher and then doing something that tries to use that data immediately. And really, that's only going to work if you're using the value from that publisher in the block here. And if you're not using that value in the block and you try to use the array directly, you'll find that it's not set. Okay, so our city weather view controller is almost complete. We have it working against the API, but there are a few drawbacks. We're not using caching at all, and that was something I wanted to add. And we're also not sharing any of that data with this screen. So we'll tackle that in the next video. So last time we got our app basically working by implementing this weather publisher. And as we saw, the main screen of the app is really just derives straight from this one publisher. Everything else stems from this. And I pointed at this problem of share being kind of a band-aid that allows it to work right now. But if we ever have any situation where a future subscriber comes to this publisher and subscribes after this weather publisher has already delivered its value, then that value will never be delivered again. It'll just get the completion for this thing. So it does kind of solve the problem if you're going to subscribe to them like immediately, but I don't like this as a solution to this problem because I want to treat this as a way for me to get the weather at any point in time. And if the weather is there, then give it to me. If it's in flight, then I will wait for the results. And if it hasn't even been requested yet, then we can make that request. So additionally, I mentioned that I want to take advantage of this timed cache, which I added to this view model, but I never actually used. And I'm going to delete it from here because I think that both of these solutions of sort of how to fetch the weather and kind of save and share the results with future subscribers, and also how to cache this data and when to return the cache, I think all of that doesn't belong in this view model. We need something to sit in between this API and our view model. So I'm going to introduce a new class here, and I'm going to call this Weather Manager. Now, usually I am not a fan of things called managers. I think this is an overused term, and it doesn't really describe often what the class is doing. I don't have a better name for this, but I do think that I'm going to run with it for now because the idea here is I want it to be able to provide a funnel point for all of my weather requests and manage all the caching for me. So to that end, we're going to create a cache, which is going to be a timed cache. And this comes from WeatherKit. And we'll also need to import combine here. So that'll be a timed cache of the type one call results. And we can just initialize that as a timed cache like this. And then we're also going to need some cancellables. And we can initialize that to an empty set. Okay, so the API that I want to use for this is going to be called Weather Publisher for City. You pass in a city, and it's going to give you back an any publisher of that one call results, optional, and never. So again, we're just going to kind of swallow errors and return nil here, and we'll log them if we see them, and that should be fine for now. So what I need to do is basically move this code into there. So I'm going to move that over here. And at this point now I'm realizing, okay, I actually don't want to get a regular publisher out of this. I want something that can retain its value and pass that value to future subscribers. And that is actually done with a current value subject. And if I want to get the weather for a city and I've already requested it, I want to return that same subject back. So what I'm going to do here is create a private var subjects. And this is going to be a dictionary where the key is a city and the value is our current value subject for one call results and never. And I'll initialize that to an empty dictionary. So right here, I can say if we have a subject already, so that'll be subjects for this city, then I can just return it and then call a race to any publisher so the types will match. If I don't, now it's time for me to fetch the weather. So I'm going to actually move this into a separate method. We'll call this private func fetch weather for a city. That'll return in any publisher. And actually what I want this to do, instead of returning in any publisher, I actually just want to pass in the subject, current value subject like this, and one call results and never. So the idea here is instead of returning a publisher, we're going to send the value through this subject. And that way I can keep this one focused on managing the subjects and this one focused on the weather. So here, what we can do is instead of replace error with nil, I will catch error in, and we'll have to tell it what we're returning. So this will be just one call results, optional. And I'm still going to return nil, but this time I want to print out the error so we can actually see it. So we'll say error fetching weather for city and pass in the city's name. And then we can also pass in the error. So we no longer need that share. What we need now is a sync, which will use unknown self in. That's going to actually give us the weather. And now I just need to take that and send it through the subject. And then we want to store this in our cancellables. That needs to be just nil. Okay, so now we've got this sort of fetching happening, and I actually want to know when this is happening, so I'm going to use handle events. And inside of here, we're going to implement the receive subscription block. And I'll ignore the subscription, but I just want to print out that we are fetching weather for city.name like this. And that way it's going to be obvious in our console when this is actually happening. And because we're implementing caching, I want to know when we're actually doing a fetch and when we're actually returning something from the cache. Okay, and speaking of the cache, if we got a weather in here, so if let weather equals weather, then I want to actually set that in the cache. And that's going to require me to add a cache key, the value that we're going to cache, which just needs to be the type that we declared in our timed cache, and then when it expires. So I'm going to go over here to our cache group in WeatherKit. Let's add a new file here, and I will call this city plus cache key. And we'll create a public extension on city with a var cache key, which is a string. And I just need to return something unique for this cache item. And so we're going to use string with a format. And inside of here, we're going to pass in the latitude, which will be a floating point number with 2 decimal places, and then a pipe character with the longitude, and again, 2 decimal floating point number here. So that'll be city, or rather just latitude and longitude. Now, the interesting thing about caching with latitude and longitude, where you chop off significant digits off the end of this item, is that you can actually get more aggressive caching for the same kind of general area, because as you lop off significant digits off to the end of a floating point number in a latitude and longitude coordinate, the number sort of gets more general. And so this is actually advantageous for us in a simple app like this, a simple demo app where I'll get the same cache key even if I move 100 feet to the left. And so, that actually works in our favor. In a real app, you may need to tweak this sort of strategy so that you return weather that's a little bit more specific to that user's location. But I thought it was pretty interesting that our choice of cache key can actually have an implication on our performance. So now I can say city.cachekey, and that'll be available after I build WeatherKit. And then I need to pass in the weather here, and then when this expires. And I'm just going to say date.adding time interval, and we'll use 60 times 60, which is 1 hour. So we're going to cache any result for 1 hour, and this should be working. Let's see what this error is. Let's give it a build. Okay, so at this point, now we've cached a value. And now I want to use the cached value, which is actually going to happen here in fetch weather. So again, before I actually make this call, we want to see if we get a cached value out of the cache for that city. And that's actually implemented like this, city.cachekey. And the behavior of this timed cache is that when you get the value, if it's expired, it'll just return you nil. So we can now pull out any cached value and just send that directly to the subject, subject.send cached value. And otherwise, we'll get this. And then because we're printing out when we're fetching, we might as well also print out when we're returning a cached one. So now here I can say print returning cached weather for city.name. Okay, so now back over to this weather publisher for city. If we now got that, now we can create a new subject, which will be a current value subject of one call results, never. Then we can call fetch weather for city and pass that into this subject like this. And what we need to do now is store this subject. And our initial value here is going to be nil because we don't have any weather right now. So we need to store this under that city like that. So the next piece of code that comes asking for a weather publisher, we'll just get that one. And then here I just need to return subject.erase to any publisher. And I think I'll clean this up by moving this out of an else block because we are returning in the block above. So I think this looks a little bit cleaner. Okay, so now we've got a way to get a weather publisher from anywhere in our app. We just have to have access to a weather manager. So let's go over to our world type here, and I'm going to add var weather manager here, which will be a weather manager. And then when I create one, I need to pass in a weather manager. Now it is kind of important to note that our weather manager depends on the weather API. And so you need to be a little bit careful when doing something like this, where this thing is dependent on current.weather API, but it doesn't do that in the initializer. So because it doesn't do that in the initializer, we're sort of okay here that the weather API access will happen later. But you want to avoid getting in a situation where I can't create this because because this depends on the other thing. Another way to do that would be to pass in API equals, pass it in directly like that, which is another option. You could also look into dependency injection frameworks to do this sort of thing. And another thing to consider right now is maybe you don't want Weather API to be accessible from everywhere anymore. Maybe you just want Weather Manager to be accessible. And that's also a valid choice here because you kind of want to funnel all of your requests through this one type, and you can structure your code to sort of influence that behavior. Okay, so now that I have Weather Manager accessible for our app, I'm going to go over to our city weather view model. And now we need this weather publisher, and now I can just use current.weathermanager.weather publisher for city. And this is already the right type, and it already implements caching. So let's go ahead and see if this works. Okay, so we've opened up our console because we want to pay attention to the results that are happening here. I tap on Portland and it says fetching weather for Portland, and it actually cached that value in the cache. So now if I quit and restart the app, it's not going to actually make another API call. Now if I go back in again, this is going to return the shared publisher, the current value subject, for Portland, so it doesn't need to actually go get it again. And then if we go to Houston, now it doesn't have the weather for Houston, so it'll go get that. So let's add a couple more cities here. Let's go over here and we're going to add Atlanta. And now as soon as I select that, it says fetching weather for Atlanta. And of course I can go back into it and it still works. I can go over here and say we want to add Philadelphia. Okay, so this is working really great. It's sharing the values and caching them. So when I run the app the next time, it's going to show cached weather for those locations. So now I want to turn our attention to this screen, which currently is just showing -- for the temperature. So let's go over to My Cities view model, where we are taking the cities out of Cities Store and mapping those over to city view models. And you can see here that we were passing in the city, but for the weather, we didn't have that yet. And so we just needed to pass in something. So we used just nil here. But now we can use current.weathermanager, and we can get a weather publisher for this city. And the type already matches. And so we're good to go. So what's going to happen now is when I run this and we take a look at the results here, it starts fetching the weather for the items that it needs in here. It goes and gets them. Some of them are already cached, so it doesn't actually hit the API. And when I go load the data for that city, the data is already there. So it doesn't really matter which path we take. If it fetches the data for this, or fetches the weather for this city on the My Cities screen or on the other screen, can be anywhere in your app, as long as they all funnel through that same publisher, and then they'll all share the same results. So I think this really shows the power of using combined publishers to distribute your data across multiple screens and not have to worry about data races about, well, if I subscribe to this publisher while it's in flight, I need to do any kind of special cases. All of that is just baked into Combine. And I think this example shows that in practice. So with that, we have a functioning weather app that uses Combine.